Hello everyone, welcome to Intellipaat's live workshop on DevOps and cloud integration. So today's workshop will be conducted by Mr. Ravi, who is a senior DevOps engineer at PlanView. He has more than 8 years of experience in the field of DevOps, and I'm pretty sure that he has a lot of wisdom to share. So without any further delay, let's welcome Mr. Ravi into the session. Sir, over to you.
Thank you so much. Hi everyone, how's everyone doing? So as you already got a small introduction about myself, right? So I'll just add a bit more onto this, onto that. So yeah, my name is Rabi. Currently working with a company called PlanView, and I have 8+ years of experience in the IT industry. I have been working on AWS and DevOps. So infrastructure and everything we are managing it on AWS, and then we are setting up the CI/CD pipeline on your DevOps. Okay, so welcome to this webinar. So as you all know, so this is going to be your cloud with your DevOps with cloud integration. So what we are going to do here is we are going to get an idea as to, or rather we'll understand what is cloud, why we have cloud, then what is DevOps, why we have DevOps, and how we can integrate this cloud with DevOps, creating your pipelines, setting up CI/CDs, right? The fancy words that that is running hot as of now. So as we move on, we will also look at some of your hands-on, maybe like launching an instance server, and then maybe installing some tools and everything, right? So what we will do is we will get started with your cloud first. We'll do an introduction to cloud, get a basic understanding of what exactly your cloud is, then what are the various vendors we have as part of your cloud, and then we'll move on to your DevOps. And then again, we'll see a list of tools that are available as part of your DevOps. Okay. So like I said, what we will do is first we will understand what exactly your cloud is, why we have cloud, what does your cloud provide when compared to your on-premise infrastructure, right? Now, your cloud computing, it's simply your data center, right? So let's say you have an application, you want to you have developed an application, you have developed the software, and you want to run that application. Okay, you want to deploy that application, you want to host it for your end users so that they can start using that application. Now, before you host that application, you need some kind of a platform to host or to deploy that application, right? Which is what we call it as your data center. Now, your data center is, it's a collection of different components. So when I say different components, you have your servers, your machines, then you have your networking component, which helps in your networking, your DNS, your routing and everything, your firewalls. Then yeah, your storage, which is your, like, hard disk, your RAM, all those things comes into the picture. Then you have your monitoring. So you have lots of components, right? Now, the problem or the issues that you have with your data center. Now, let's say, you have your on-premise data center, meaning you have everything physically available. So you have physical machines, you have physical servers, you have physical storage, physical, everything is physical. Now, generally, when you want to, let's say, start a new company, or you want to host a new product, what you'll have to do is you'll have to create your infrastructure first. So you do a general analysis as to, okay, this is the capacity I need to run the applications for my end users. Now, the problem here is, depending on how your product turns out, right? So let's say, you have good response from your end users, so whatever the infra you have set up works fine. If you don't have a good response from your customers, then whatever the infra that you have set up, it's gone, right? It's a dead investment. Either you have to sell it off to others with a lower cost, or basically keep it for future use. Now, that's one. Second thing, let's say, you want to kind of migrate. Let's say, for example, you want to migrate from one location to another location. Now, that's another problem that you have when you want to migrate your infrastructure, right? Now, what if you can virtualize these resources, right? So you can have your virtual machines, you have your virtual networking, virtual storage. So basically everything is virtualized. You don't have any physical resources. One. Second thing, what if you can move it to the internet, right? So you can access these virtual resources over the internet. You don't have to be physically present in a particular location to access those resources. What if we can do that? Now that's where your cloud computing comes into the picture. So cloud computing is simply virtualizing your resources over the internet. So you can access these resources from anywhere you want, right? So cloud computing is also your infrastructure, okay? But it's just that you'll have different vendors, and you can basically start using, you can start creating these resources, you can start deploying your applications whenever you want. So this cloud computing, it's simply a on-demand platform that you have for setting up your virtualized infrastructure. Okay, so one, it's on demand, and you can request for any resource you want. It could be your compute power, it could be your database, it could be your storage, it could be your networking, it could be in applications, it can be anything, basically A to Z, whatever you want, right? You can get it from your cloud computing vendor, and all of this will be over the internet, right? So like I said, you can access these resources from anywhere you want as long as you're connected to the internet, right? And all of these resources, they follow your pay as you go pricing. Now when I say pay as you go pricing, you're only going to pay when you're going to use those resources. So let's say I launch a server, I launch a virtual machine, and I'm only going to pay for it when I'm going to use it. If I'm not using it, I don't have to pay any money. Likewise, let's say I have a storage, and I'll only pay when, let's say, I utilize maybe a 1 GB or 2 GB or 3 GB, whatever storage I have allocated. I'll only pay when I use those storage, right? So this is what we call it as your cloud computing in simple terms. All right. So your cloud computing obviously provides you a lot of advantages when compared to your on-premise or your the data center, your physical data center. So it has few characteristics that makes it stand out in the market, right? So one, it's your on-demand self-service. So when I say on-demand self-service, so everything is on demand, meaning you can request for the resources whenever you want. Okay, so let's say you want like 100 machines right now, you can go and launch 100 machines right now. Or maybe you need like a terabyte of storage capacity, you can get the terabyte of storage capacity. And all of this is self-service. So there's no human interaction, everything is automated, right? So it's more like a point and click um, application that you're going to use and request for the resources. Okay, then it also provides you a broad network access. So when I say broad network access, you can, it follows your heterogeneous model, meaning you can access these resources from any platform you want. It could be your mobile phones, it could be your tablets, your laptops, your workstations, basically from anywhere you want you can access it. Because it's over the internet, over your network, you can access it from anywhere you want. Then you have your resource pooling. Now, any cloud computing you take, it follows your multi-tenant model. When I say multi-tenant model, multiple customers can come and request for the resources at the same time, right? And the cloud computing is designed in such a way that it will be able to accommodate those requests, whatever the customers is giving. So let's say all of us, we can go to the cloud computing at the same time, and we can request for whatever resources we want. So maybe I need 10 servers, you need 20 servers, some storage, some networking, right? So because it follows your multi-tenant model, multi-tenant is basically multiple people can access the resources at the same time. Okay, then rapid elasticity. So the other important feature that you have of your cloud computing is the elasticity. Now when I say elasticity, let's say you have your on-premise data center. Okay, now you want to scale up your infrastructure, maybe you want to add up a few more resources. Now that can be very challenging because you have to get quotations from various vendors, you have to procure the resources, as do the assembly, so it can be very time consuming. But with your cloud computing, everything is automated. So whatever you want, you can go and scale up, you can scale down depending on the requirement. As and when your demand increases or decreases, you can request for more resources or you can destroy the resources as well. Okay, and everything that you do in your cloud computing can be measured. Okay, so you can leverage metering capability. So basically you can see how much of storage you have utilized, how much of for how many hours you have run the servers, for how many days you were running the server. So everything can be monitored. You can generate reports, so you have a proper transparency when we talk about your vendor and your consumers. Okay, now these are some of the characteristics, important features that we have generally when we talk about your cloud computing. Now let's say you're looking for a solution where you can host your applications on the cloud computing. Now the first thing that you'll have to do is you'll have to decide between the three service models that we have when we talk about your cloud computing. Okay, so the three main models that we have your infrastructure as a service, we have platform as a service, and we have your software as a service. So basically, which model you want to use as part of your infrastructure. Now, if you're going with your infrastructure as a service, that means you are going to manage everything, starting from your machines to your applications to your storage, your networking. Everything will be managed by you, right? So this basically contains the building blocks, and you will be responsible for all the setup, in addition to deploying the applications as well. Okay, so everything will be under your control. All right, the next model you have is your platform as a service model. Now under this, you're telling that, okay, I am not going to worry about the infrastructure management. I am only going to concentrate on my application development, and I want the vendor to provide me the infrastructure. For example, okay, let's say you have these e-commerce websites, right? Flipkart, Amazon, and everything. Now as a seller, so let's say I am a seller. Now I don't have to worry about the platform, the application, the e-commerce application, right? All I have to worry about is my product, right? So Flipkart and Amazon, they are responsible for managing that platform, developing the application, deploying the application, hosting the application. Everything will be taken care by the vendor. And me being the seller, I'm just going to take my product, showcase it on the platform, and I start selling it. Now that's what we call it as your platform as a service. So you're not responsible, you're not going to manage the infrastructure. Rather, you're only going to focus on developing your applications and deploying your applications. Okay, and the third option you have is your software as a service. Now under this option, you're not going to worry about your infrastructure management as well as your application development. Okay, so all these are your end user applications. So any applications that we are using on a day-to-day basis, like your Microsoft Outlook, your Slack, Microsoft Teams, Gmail, all these are your software as a service, right? So let's say if it's your Microsoft Outlook, so Microsoft is responsible for developing that application, managing the infrastructure where that application is going to run. We being the end users, we are only going to use that application, right? So that's your software as a service. So these are the three general models that you will get whenever we talk about your cloud computing. Now most of the time we end up using the infrastructure as a service because we want to have sort of more control over the infrastructure that we are going to set up, right? Now once you're done choosing the service model that you want to use, the next thing you have to decide is how do you want to implement that cloud model, right? So under this, again, you'll have three options. So you'll have the public cloud, you will have the private cloud, and then you'll have the hybrid cloud. Okay, these are three options you have. Now public cloud is basically, it is open to all. Anyone can use it. For example, let's say your let's say the e-commerce websites itself, right? Now that is open to all, right? Anyone can open up that application, they can use that application. That falls under your public cloud. So the cloud infrastructure is provisioned for open use, so it's open for the general public, right? Even though it is owned by a company or by a certain organization, it is open to all. Okay, that is what we call it as your public cloud. Then you have the private cloud, which is restricted to a group, right? To a group of people or to an organization. So, like for example, let's say you have your organization's internal applications. Now, those internal applications can be accessed only by the employees of that organization. Right? So that's your private cloud. It's not open to all. You have restricted access to that. Only a certain group of people or the consumers can access that infrastructure and the application. And then you have the hybrid cloud, which is a combination of your public cloud and your private cloud. So some of your resources will be public, which is open to all, and some of your resources will be private, which is restricted only to a certain business unit or to a certain group in the organization. Okay. Now, the models, whatever we have looked at, or any cloud models or a cloud computing that we take, it provides you a lot of advantages when compared to your on-premise data center. So the first advantage that you get with your cloud computing is your money. Okay, so let's say for example, you have your own data center. Now to manage that data center, you'll have a yearly budget, maintenance, security, patches, updates, everything is money, right? So you'll have to basically allocate budget and use that budget to manage your data center. But with your cloud, you don't have to do any of those things, because this cloud is managed by a different vendor. They will be responsible for managing that data center or managing the infrastructure. So you can trade the capital expense for variable expense. So instead of having one fixed budget, you can go with a variable expense where, depending on your usage, depending on what you are consuming, you'll have to pay the money. Okay. Benefit from massive economies of scale. Now, let's say you go to shopping. Okay. Now let's say there is a sale. Now the sale is, let's say, buy 5 get 50% discount, or let's say buy 10 get 70% discount, and then so on, right? The same goes in your cloud computing as well. The more and more consumers you have, the better costing will be there for your resources. Okay, so more and more people are using this platform, any cloud computing platform. Accordingly, your cost will be allocated to the resources. Okay, then stop guessing capacity. So the other advantage that you have with your cloud computing is you don't have to guess your capacity. Like for example, let's say I have 10 customers today. Now I just need to set up the infrastructure for those 10 customers. I don't have to, like, do an analysis and set up the infra beforehand, right? So for now I need only for 10 customers. I'll set the infrastructure accordingly. Let's say next month I get 10 more customers. I'll simply scale up the infrastructure. I don't have to set it up beforehand. So you don't have to guess any capacity. Then increased speed and agility. So anything you want to scale up or scale down in your cloud computing, everything is a click away. So like I said, there's no human interaction. So everything is automated. So anything you want to do, you can do it very quickly. It takes very less time for you to set up the infrastructure, deploy your application, and get started with it. Then stop spending money on running and maintaining data centers. So because you're not going to have a physical infrastructure or a data center, you don't have to worry about maintaining those data centers. The cloud computing vendors, they will be responsible for maintaining the data centers. And then finally, go global in minutes. So you can deploy your applications and you can make it available for your end users within minutes, like 2 minutes, 3 minutes, depending on the application what that you have written. Okay. Now, though it has advantages, it also has few concerns that you may want to keep in mind. One, someone else is looking after your data. Think of it, like a bank. We have a bank, though it's our money, but the bank is looking after the money, right? The same way in your cloud computing, the vendor is looking after your data. Then you have cyber attacks. Now, because everything is over the network, over the internet, if you don't have proper firewalls, if you don't have proper, locks, there are high chances that people can hack into your network and they can steal your data. Then insider threats. So insider threats is basically people within the company, right? So they may also expose certain sensitive information to the outside people, which can cause problems to the organization. Then government intrusion. So government intrusion is the government can reach out to the company asking for XYZ customers data at any point they want. And then finally legal liability. So if any of your customers data is exposed, right, so obviously people will sue you, right? So there will be a lot of legal liabilities if you're not protecting the customers data, right? So this is generally what we have when we talk about your cloud computing. Okay. That's your introduction that I have as part of your cloud computing, right? To talk about the vendors that we have about your cloud computing. So now, see, generally when we talk about your cloud computing, we have lots of vendors that provides you the cloud services, right? So the popular or the top three cloud service providers we have AWS. AWS is basically your Amazon Web Services. Then we have Microsoft Azure. We have GCP, which is your Google Cloud Platform. So we have Red Hat, we have Rackspace, we have Verizon, we have Salesforce Cloud, we have Alibaba Cloud, we have DigitalOcean. So yeah, I mean, we have lots of cloud service providers, right? Yeah, Dell also has cloud, right? So you have lots of cloud providers that you can choose from, but generally AWS, GCP, and Azure, these are your top three, as of now at least, who are basically the leaders when it comes to the cloud services as part of your infrastructure. Now, AWS has been the market leader for quite some years now. I think 7 to 8 years. Constantly, they have been the market leader. They have been one of the most widely used. They have the largest market share compared to the other cloud service providers, right? So uh, Azure is also catching up. They are also, trying to get more market share. But down the line, I feel AWS and Azure, they are going to, kind of have a tough competition as to who is going to be the market leader, right? So coming to this question, which cloud is better in terms of cost? See, in terms of cost, I like AWS personally. Because the reason I'm telling that is because AWS gives you lots of features. It has lots of options that you can choose from in terms of your cost, and also depending on the scope that you have for the infrastructure setup, you can always negotiate with AWS, right? So they do reduce the price, right? So for me, I personally feel AWS is much better in terms of your cost, in terms of your functionalities, in terms of your features. Okay. So what we will do is we will look at your AWS. We will go over the console. We will understand like what all services AWS provides, and then maybe we will look at launching a virtual machine, connecting to the virtual machine, right? So okay, so now so AWS, it stands for Amazon Web Services, and this was started way back in the year 2006, right? So it's quite old, and AWS has grown a lot in the market. They are doing doing the business in billions per year. So they have a huge market share. They have been in this industry for quite some time now, and there are lots of things that AWS has introduced. Your machine learning, your IoTs, your data analysis, then networking, geospatial services. So there are lots of services that AWS provides. Okay. Now to begin with this, ideally, you can create an account in AWS, which we call it as your free tier account. So you can go to this aws.amazon.com. That's the URL, and you'll have to create an account in AWS. Now, if you're creating this account, we call it as your free tier account, which is valid for 12 months from the date of account creation. So when I say free tier account, you have certain free usages. Now, not everything is free. Depending on what you're launching, depending on what you're setting up, you may have to pay money depending on the usage. But there are certain privileges where you can work with it without paying any cost. So there's a certain limitation, and as long as you're within that limitation, you don't have to pay any money. If you go beyond that limitation, you'll end up paying money. Yeah, so once start working on AWS, make sure you know the limitations. Like for example, your EC2 instances. Now, EC2 instances are nothing but your virtual machines. Now, these virtual machines I can run up to 750 hours per month without any cost. Now, if I go above 750 hours, I'll have to pay money. Now, likewise, you have certain limitations. So as long as you're within that limitations, you don't have to pay any money. If you go beyond that limitation, you'll have to pay the money. Okay. Now, so here you can sign up. It's a very straightforward setup that you have. You'll have to. It basically has 5 steps. So you need to give your email ID, your username, your password. That's your step 1. Step 2, you'll have to give your address information. Step 3 would be to you give your banking account information. So you'll need to add your credit card. Now don't worry, they will deduct 2 rupees from the account just for the account verification purpose. It can be a credit, it can be a debit, anything is fine, and the amount will be refunded back to you. And your card will be charged only when you authorize it. So even if you're adding the card details, don't worry, Amazon will not deduct any money from it automatically unless you authorize that. All right, but you will need to have a card. Without that, you won't be able to sign up. Next step, you'll need to do some confirmation, like your phone number confirmation and all those things. And then finally, you'll have to select your account type. Like you want to create a business account or an enterprise account or a free account, what you want to create. So these are the steps you'll have to follow. Like I said, it's very straightforward. You should be able to create the account without any issues. Once you have the account, you can start using it. It takes like 2 to 3 hours for your account to be ready to use. So let me log into my account here. Right, so this is my AWS account. So when you log into your AWS account, this is what you will see. Maybe this will be empty because these are my recently visited services. Here you can see the overall health, your cost, right? And you'll find few solutions. And here on the left hand side, you can see these services, and this is what AWS provides. So you have analytics, AR and VR, cost management, blockchain, containers, database, front end, game development, IoT, machine learning, media services, networking, quantum technologies, robotics, satellite. So you have lots of services that AWS provides. So there are like many things that you can do if you decide that you want to work with AWS. So anything you want to do, you can do this. So you want to containerize your applications, you can use ECS like Docker or Kubernetes. Or maybe you want to have virtual machines, then you can quickly launch EC2 instances. Or you want to develop some games, you can work with this game development services. Or let's say you want to work with your machine learning, AI or ML, that is also fine, right? So you have lots of services that AWS provides, right? Now, we want to look at your compute. So compute is nothing but your machines, and this is what we will come back to this. This is what we are going to look at. So EC2 is nothing but your virtual machines. Okay. So at any point, if you want to set up any virtual machines, we make use of your EC2 service for that. So this, gives you load balancing, it gives you auto scaling, storage, your RAM, CPU, everything will be controlled here itself, right? So anything you want to virtualize, you can use these virtual machines, quickly launch the virtual machines, um, then connect to the virtual machines, and you can start deploying the applications that you want, right? We'll come back to this in some time. Now what we will do is we will look at your DevOps introduction. We'll understand what your DevOps is, and then we will come back to this once again. So now that we have an idea as to what your cloud computing is, what is AWS, right? Now let's understand what is DevOps. In now talking about your DevOps. Now, what is DevOps? So before we go to DevOps, it's important that you understand what is SDLC. Okay, your software development lifecycle, right? Now, any applications you take. So let's say I have a e-commerce application. I want to develop that application, right? Now there is a step-by-step process that I can follow to develop my application. Now this step-by-step process, that the steps that you're going to follow, we call that as your SDLC, your software development lifecycle, right? So under this, you'll have very common steps like your requirement gathering. So you will understand what needs to be done. So this will be your requirement gathering. Then you will have your design. Then you will have your coding. You will have your building, your testing, then deploying, and then your monitoring, right? So generally, whenever we talk about your SDLC, these are the life cycles that you will follow to develop your applications, right? So what is software development? So software development is simply your process of transforming the requirements. So let's say I'm a customer. As a customer, I'll come to you and tell you that, okay, create this XYZ application. So whatever the customers, the requirements that I've given you, you will transform that into an application, the software product. So this process that you are going to use to develop the application, we call that as your software development. Okay, so in broader terms, it has different stages to it. So you have the requirement gathering, you have the designing, implementation, verification, maintenance. You'll also have testing, deployment. So all these, generally makes up for your SDLC. So any application you take, your Java application, PHP application, JavaScript, HTML, C++, any applications you take, right? This is the most commonly used lifecycle model that we have. Okay, so what is requirements? Requirement, this is the most important phase that you have. This is where you will understand as a developers, you will understand what does the customer need. Okay, so in this case stage, the requirements are gathered from the customer. So uh, you as a developer and me as a customer, we sit down, I give you the requirements, and you try to understand what is that I'm asking for, right? And you also do the analysis whether it is doable or not, whether it is feasible or not, right? So whatever the requirement I'm giving you, it should be meaningful, right? Just because I'm a customer does not mean I can give you whatever I want. It should be meaningful, it should be doable, right? So that's what we do in your requirement gathering. Then once you're done understanding the requirements and everything, you start designing that application, right? So as an architect, there will be an architect who will basically draw the technical specifications, like how many servers will be needed, how much of CPU, how much of RAM, how much of storage, your monitoring, then your the DNS, the networking, all that technical specifications will be done, and a plan will be designed for the various software components. That's your designing phase. Once you're done with the designing phase, you start implementing it. So as developers, whatever the technical specifications you have got, you start developing that into an application. So basically start writing the code, which is simply developing the application. Then you have the verification. This is where you basically do the validation of your application. Your testing and everything happens here. So once the development team has done working on the application, you'll have a group of testers, like your automated testers, your manual testers, right? Your QA team basically. They will start developing the application's functionality based on the specifications given by the customers. Okay, and then finally have the maintenance. So maintenance is, once you're done deploying the application, maybe there are bugs or there are some enhancements or you want to do some optimizations. All those things can be done in the maintenance phase. So once your code has been verified, it can be pushed to production, it can be deployed to production, and every now and then you can keep an eye on your application, making sure everything is working as expected. So this is what we call it as your SDLC or software development lifecycle. Now, when we talk about the SDLC, we have three popular models that you can choose from. Okay, so since the time software development was started, there were lots of models that have been introduced. Each of these models, they help you to solve the problems from the earlier models. Okay, but traditionally you have three major platforms. Sorry, so you have three major software development tools that you can choose from. So you have the waterfall model, you have the agile model, and you have the lean model. So waterfall model is the oldest model that we have, and as of now you'll see many projects running on agile model to develop the application. So let's talk about each of these a bit more one by one. So under your waterfall model, again you'll have like the different steps: your feasibility checks, your analysis, your designing, your coding and testing, your integration and system testing, your maintenance and windows, all those things. So waterfall model was among the first model that was introduced to follow the SDLC. Okay, so this waterfall model follows your linear approach. So when I say linear approach, you cannot go to the next step until the previous step is completed. For example, let's say you cannot go to the analysis phase until your feasibility check is completed. Only when you complete this, you will be able to move on to the next steps. Okay, however, this has some problems. We'll come to that. So coming to the advantages of your waterfall model, you have clear objectives. So you're very sure as to what needs to be done, and you have clear objectives. You have specific deadlines. So let's say you have said that you can complete it in 2 months. So that's your specific deadlines. You have to make sure that you finish it in 2 years. Sorry, 2 months, right? And then no ambiguous requirements. So when I say no ambiguous requirements, let's say as a customer, once I come and give you the requirement, I cannot keep on changing it. If I keep on changing it, the time taken to develop that application will increase, and also it may create conflicts with whatever is being developed right now. Well understood milestones. So as a developer, you will be creating milestones, and when to complete those milestones. So you have well understood milestones, and then process and results are well documented. So anything you are going to do in the waterfall model, everything will be documented. It could be something like connecting to the server, it could be something like troubleshooting your applications. Everything will be documented. Okay, however, it also has some disadvantages. So working product is not available until the later stage in life cycle. So let's say as a customer, I'll come and give you the requirement, and you are following the waterfall model. Okay, now as a customer, I will not know what the application is looking like until a very later stage in the software development, right? Because of that, as a customer, uh, I may either be happy with whatever you have developed, or I may not be happy depending on what you have developed, right? So this is a very poor model for very large and very complex projects, and it cannot accommodate changing requirements. So once I come and give you the requirement, I cannot keep on changing it. If I keep on changing it, that's gonna cause a problem with the deliverables. And then high risk and security. Okay, so these are some of the disadvantages that you have with your waterfall model. So now, to solve the problems that you have with your waterfall model, the next model was introduced, which is your agile model. Okay. Now, your agile is basically breaking down the requirements. So with your waterfall model, what happens is you'll have one single big release. Okay. So everything will be deployed in a single shot. Okay. But in your agile model, you're breaking down the requirement into smaller features, and you start deploying those features in a repetitive cycle. So like, generally in this we follow a 2 week sprint or quarterly model. So it's most commonly is your 2 week sprint, wherein we take certain requirements and we try to finish those in 2 weeks, right? Now, the advantage that you have with this agile model is that your customers is given the first preference, right? So in your waterfall model, the customers will not know what you have developed until a later stage. But with your agile model, because you are breaking the requirements into shorter releases, so like every month or every by a couple of weeks you'll have a release, and you will deliver something to the customer. Now that way, as a customer, I will know what exactly you're working on, and you being the developer, you will also know whether the customer is happy or not, right? So every sprint you will have the priority request, so you'll prioritize things, you will design, you will code, you will test, you will release it. Again, in the next sprint you'll have the priority request, design, code, test, deployed, right? So this cycle continues. So this is what we follow in your agile model. So your customers satisfaction is given high preference, less planning is required because you don't have to plan for the entire application. The planning, the effort that goes into planning is less. Requirements can be dynamic in nature, so you can change the requirements as and when you want, and the functionalities can be created and tested much quickly. Okay. Now, this also has some disadvantages. This is not suitable for handling very complex dependencies in projects. So let's say one component depends on another component, and that component in turn depends on another component. Now, that is very difficult to manage in your agile model. Okay. Then knowledge transfer to colleagues can be difficult since there is little documentation. So the other problem we might have in agile model is your documentation. Not everything is documented. So let's say if I'm leaving the company, knowledge transfer can be a challenge, right? The person who is going to replace me, it's going to be difficult for them because of lack of the documentations. And the success of the projects depends completely on the customer satisfaction. Whether the customer is satisfied or not. Whatever the interaction you're doing with the customer, it heavily depends on that. Okay, that's your agile model. Now, to overcome the challenges that you have in the agile model, your lean model is introduced. Lean, to a certain extent, is also same as your agile model, but there are few more additions to this. So this follows seven principles for your lean. So eliminate waste, amplify learning, decide as late as possible, deliver as fast as possible, empower the team, build integrity, and see the whole picture, right? So lean development is a philosophy of increasing quality in your software development by following the same agile methods. Okay. You can also ignore the clutter for later and focus on what is needed right now. So under this, instead of working on something that is not needed, you will try to work on something that is actually needed. That is something that can be really useful. So lean methodology has its primary focus on two things: respect for frontline workers and continuous improvement. Okay, so this also follows your agile model only, but there are few more additional steps to this. So the advantages carries the same advantage as agile methodology, creates a positive working environment. Customer feedback is given the utmost importance, and limiting wastes save money as well as your time. Okay. Again, the disadvantages this is largely dependent on the skill sets, basically the team, whether you have the right set of people, those people, whether they have the right set of skill sets, it largely depends on that. No room for error. Missed delivery can be bad for business, and the success of the project depends heavily on the customer interaction. Okay, so these are the three models that we have. So once again, a quick overview of your waterfall, agile, and lean model. So with your waterfall model, you have one single big deployment. Okay, and the customer feedback is taken only at the end, right? So the customers, as a customer, I will not know what exactly are developed on, and whether I'm happy or not does not really matter in the waterfall model. In your agile model, you're basically breaking down the application into smaller features or smaller requirements, and you'll have a recurring cycle. So requirement design, implementation, verification, release, customer feedback. Again, requirement design, implementation, verification, release, feedback, and you follow the same cycle. In the lean model, it's also the same. That only difference is you also prioritize things. So when you go to the next cycle, you prioritize what is actually needed and you try to minimize your waste. That's the only difference you have with your agile model and your lean model. So the problem with waterfall model was that the development lifecycle took a lot of time to develop the application. Therefore, by the time the product was finished, either the customers, the requirement would no longer be the same. So let's say you took 1 year. Now, by the time you deliver, maybe my requirement has changed, right? The problem was fixed by your lean and agile methodologies, and these methodologies strictly focus on customer feedback and also improving the quality of the applications that you have developed, and that too in shorter development cycles. Okay, and this brings us to DevOps. Right? So we already have agile, lean, waterfall. Why do we need DevOps? Right? So although the software quality was improved, there was always a lack of efficiency between the development team. So generally, when we talk about your software development team, it consists of your developers who develop the applications, and then you have the operations who are responsible for deploying that application, right? So let's look at the job role. So your developer's job is to develop the application, and once the application has been developed, they pass the code to the operations team. Now the operations team is responsible for testing that code, providing feedback to the developers if any test cases have failed and if there are any bugs, and if all goes well, the operations team will simply upload the code to the build servers. Now, however, there was always a communication problem between the development team and the operations team. Okay, the development team, the developer, will run the code on their system, and they will test it and make sure everything is working on their system, and they forward that code to the operations team. Now, what operations team will do is operations team will try to run the same code on their system, but it will not run. Okay, so what will happen? The operations team will simply reach back to the developer telling that, okay, the code is faulty, it's not working as expected, there is a bug, the feedback is given. But the developer will simply tell that, no, everything is working fine on my system. There is something wrong, with what you're doing, so it's not my fault. So there's a lot of back and forth that goes on between the development team and the operations team, right? And to solve this problem between these two, your DevOps was introduced. So DevOps is simply your dev from your developer, ops from your operations working together. So that is your developers and your operations team will be working together as a single team. And that's how your DevOps was introduced. Okay. So talking about in terms of your traditional IT infrastructure and DevOps, your traditional IT infrastructure is less productive, DevOps is more productive. Your traditional IT is skill centric team, so you'll have a testing team, you'll have a development team, you'll have an operations team, and so you'll have skill centric team. While with your DevOps, the team is divided into specialized silos. Okay, traditional IT more time invested in planning. DevOps, small and frequent releases lead to easier scheduling and less time in planning. And then finally, traditional IT, difficult to achieve the target or the goal, DevOps, frequent releases with continuous feedback makes it achieving the targets more easily. So what is DevOps? Your DevOps is also a software development methodology, and you can use this to improve the collaboration between the development team and the operations team by using a variety of tools, the automation tools. Now, these automation tools are implemented using various stages, which are part of the DevOps lifecycle. Okay, so generally when we talk about your DevOps, you'll have your coding, planning, testing, build, release, deploy, operate, monitor. Everything will be done in a continuous manner. So you see this is basically the infinity symbol, which is nothing but your continuous manner. Okay, so now, when we talk about your DevOps lifecycle, here, so you have your planning, you'll have your coding, your build, your test, release, deploy, operate, monitor, right? Now, for each of these, we'll have different phases. So for planning and coding, we have your continuous development. For building and test, we have continuous testing. For release and deploy, we have continuous deployment. For operate and monitor, we have continuous monitoring. And then at the heart of your DevOps, we have continuous integration. So let's understand a bit on each of these terms. So how does a DevOps work is, so let's say I'm a developer. Okay. So as a developer, I will develop the code and I will push it to a version control system. Once it has been pushed to a version control system, I can automatically trigger a job, which will build my code, and I can deploy this to various environments like your testing environment or your production environment, and we can test it, making sure everything is working as expected. Now, if something goes wrong, we can give the feedback to the developer telling that, okay, there's a bug or something is not working. And if everything is working fine, we simply deploy that to the prod environment. Okay, so what is continuous development? In this stage, you'll be using version control tools, tools like your Git, SVN, all these are your version control tools. And you can also use tools like your Ant, Maven, Gradle, which are your build tools. So we can use this to build your packages, your executable packages or your deployable packages. Okay, then you have the continuous integration. Now that's the critical point, or as we call it, the heart of your DevOps. Okay, so this deals with integrating the different stages of the DevOps lifecycle, and therefore it's the key for automating the entire process. Okay, then you have the deployment. So this is where you deploy the application. So either you can containerize and deploy the application or just deploy the application. So whatever the package that you have built in the previous state, right, you'll take that package and you start deploying it to your machines. Once you're done deploying it, you'll start testing it, right? So this stage deals with automated testing of the application pushed by the developers. If there is an error, the message is sent back to the integration tool, and this tool in turn notifies the developer or the of the error. So if the test was successful, the message is sent to integration tool, which pushes the build on the production server. So basically testing will happen. If everything is working as expected, the same thing will be deployed to the prod. If there is an error, the feedback is given to the developer. Okay, and then finally we have the monitoring. Now monitoring is also a very important phase that you have in your DevOps. Now anything you take, it could be a servers, it could be your applications, it could be anything, right? You want to monitor those applications, right? Or you want to monitor that infrastructure. That's where you have this continuous monitoring. So this stage continuously monitors the deployed application for any bugs or for any crashes. Okay, now it can also it can also be used to set up to collect any user feedback. Now the collected data is then sent back to the developers to improvise the application. Okay, that's basically your monitoring. Now, when we talk about this DevOps lifecycle, there are tools that we can use to automate your different steps. So generally, the tools that we cover as part of your DevOps is we have your Git and GitHub, which is your version control system. So if you're a developer, right, you want to maintain different versions of your code. Now that can be done by using Git and GitHub. Okay. Then you have Maven, which is your build tool. Now this is mainly used for your Java applications. So let's say you have a Java, you have written some Java application and you want to create an executable package of that. When I say executable package, as an end user, I will simply download that package, and when I run that package, I should get my application. Now, those kind of packages can be created by using your Maven build tool. So Maven is mainly used for your Java applications. So likewise, if you have any Android application, you can build it using the Gradle build tool. Okay. Then we have your Jenkins. Now this is your integration tool. Okay, this is the main tool. You can use this to set up your pipelines. You can use this to automate your jobs. All those things can be done by using Jenkins. Then we have your Docker, which is your containerization tool. So if you want to containerize your applications, or you want to containerize your services, you can make use of your Docker for that. We also have your Kubernetes, which is also a containerization tool. Okay. Then we have your Ansible, which is your configuration management tool. So let's say, for example, you have 500 servers. Now on these 500 servers, you want to install Java, or you want to update something. Now it's not really feasible for me to, go to each of these 500 machines one by one and then install Java or update Java. Now I can automate that by using any configuration management tool like Ansible in this case. Then we have your Terraform. Now Terraform is your infrastructure as code. Okay, so if you want to automate your infrastructure setup via code, you can make use of Terraform for that. And then finally we have your ELK. Now ELK stands for Elastic Logstash Kibana, which is your monitoring tool. So if you want to monitoring your infrastructure, you want to monitor your performance, your applications, availability, all those things can be done by using this ELK tool. But if you ask me other tools, so in place of Git and GitHub, we have Bitbucket, we have Mercurial, we have Git, we have Perforce. In place of Maven, we have Gradle, and we have what else? Yeah, I think that's all I can remember. Then you have Jenkins. Now in place of Jenkins, we have GitLab, we have TeamCity, we have Circle CI. Then in place of Docker, we have Kubernetes, we have OpenShift, we have Apache Mesos, we have Rocket. In place of Terraform, if you're on AWS, you have CloudFormation, you have Pulumi, you have Juju, right? And then finally ELK, which is your monitoring tool. So here you have Grafana, Prometheus, NagOS, Zabbix, Isinga. So again, lots of tools that are available. But like I said, these are some of the popular tools that are being used right now in the IT industry. Right. So, in terms of your continuous development, you can make use of your Git. You can use this as your version control system. Um, in place of your continuous integration, you can use Jenkins. So Jenkins is your open source continuous integration tool, and this is completely written in Java. Then for continuous deployment, you can either containerize it. So if you're containerizing, you can use Docker, Kubernetes. And if you want to manage the configuration of your remote machines, you can use Ansible, Chef, Puppet, any of those tools. For continuous testing, you can use Selenium, which is a very popular automation testing tool that we have. Then you have continuous monitoring. So there are again lots of tools when we talk about your monitoring. So we have NagOS, we have Grafana, we have ELK, we have Datadog. Again, lots of tools that are there, right? So this is how you can make use of these DevOps tools to automate your development process. So as a developer, I will develop the code and I'll push it to GitHub. From GitHub, I'll trigger my Jenkins job. Now what Jenkins job will do is it will deploy the application into my testing server. It will automatically run the test cases. Depending on the test cases were successful, the same application will be deployed to the prod. Now, if there is any error, the feedback will go back to the developer, right? And they will try to fix that. If not, you can deploy it to the prod environment and you can continuously monitor that application. So this is what I have as part of your DevOps introduction. People, then thank you so much for joining this session. I hope this was really helpful for you.
Yeah, thank you, sir. Thank you, sir, for providing such wonderful and insightful session. We thank you for giving us your precious time to us.